Have you ever looked up at the night sky and wondered about those tiny, twinkling points of light? Many of them are stars, massive celestial bodies burning billions of miles away. But what happens when a star like our Sun runs out of fuel? It collapses into something incredibly dense and strange, a white dwarf. Today, we're going on an imaginary journey to answer a mind-bending question. What if you fell into one? First, let's get acquainted with our destination. A white dwarf is the super-dense core left behind after a sun-like star has shed its outer layers. Imagine cramming the entire mass of our Sun into a sphere roughly the size of Earth. The gravity on its surface would be absolutely crushing, about 350,000 times stronger than what you feel right now. A single teaspoon of white dwarf material would weigh as much as an elephant. So, as you can probably guess, our trip is going to be intense. Let's imagine you're in a futuristic, indestructible spaceship, approaching this cosmic relic. From a distance, the white dwarf would be a dazzling, brilliant gem in the blackness of space. Its surface temperature can be incredibly high, reaching up to 100,000 degrees Celsius, so it would glow with an intense white or bluish-white light. But this isn't a friendly glow. It's radiating immense amounts of energy, including high-energy X-rays and ultraviolet radiation. Your ship would need some serious shielding unless to get close without being fried. Now, for the main event. Let's say you decide to leave your ship and begin the fall. We'll grant you a special suit that can withstand the extreme temperatures for now. The moment you start falling, you'd experience acceleration like nothing else. The white dwarf's immense gravity would pull you in with ferocious speed. You'd be going from 0 to thousands of miles per second in a heartbeat. But the most bizarre and immediate effect wouldn't be the speed, it would be the tidal forces. Tidal forces are what cause the tides on Earth, a result of the moon's gravity pulling on different parts of our planet with slightly different strengths. Now, amplify that effect by hundreds of thousands. As you fall feet first towards the white dwarf, its gravity would pull on your feet much more strongly than on your head. This massive difference in gravitational pull would stretch your body. It's a process that scientists have a rather grim name for: spaghettification. Your body would be elongated, pulled into a long, thin strand of atoms, like a piece of spaghetti. This isn't a slow, gentle stretch. It would happen almost instantly and with unimaginable force. Before you could even process what was happening, you would be torn apart, atom by atom. Every single piece of you would be stretched into a thin stream of particles, spiraling down towards the star's surface. So, in reality, you would cease to exist long before you ever reached the white dwarf itself. Your very essence would become a rain of elementary particles. But for the sake of science fiction, let us pretend our magical suit not only protects you from the heat, but also holds you together against these insane tidal forces. What would happen next? As you continue your plunge, you'd be entering the white dwarf's atmosphere. This isn't an atmosphere like Earth's. It's an incredibly thin layer of elements, usually hydrogen or helium, heated to millions of degrees. You'd be blazing through this plasma, a superheated gas of charged particles, moving at a significant fraction of the speed of light. The pressure would be building at an exponential rate. On Earth, we live under 1 atmosphere of pressure. By the time you hit what could be called the surface of the white dwarf, the pressure would be billions of times greater. Imagine the weight of 1,000 skyscrapers pressing down on every square inch of your body. No conceivable material could withstand this. Your magical suit would be instantly crushed into a microscopic speck, and you along with it. But let's push our fantasy even further. What if you could somehow survive the pressure and actually enter the white dwarf? You wouldn't be swimming or sinking. You would be merging with one of the most exotic forms of matter in the universe, electron-degenerate matter. Inside a white dwarf, gravity is so strong that it has crushed atoms together. The electrons are stripped from their atomic nuclei and forced into the lowest possible energy states, creating a super-dense sea of electrons. This material behaves in very strange ways, governed by the laws of quantum mechanics. It's incredibly rigid, more like a solid crystal than a gas or liquid. If you were to hit this surface, it wouldn't be a splash. It would be like hitting a diamond wall at a quarter the speed of light. The energy of your impact would be colossal. You and your ship would vaporize in a flash of energy so bright it would briefly make the white dwarf's surface shimmer. This explosion would release gamma rays and X-rays, a final, tiny firework against the backdrop of an ancient star. So, what have we learned? Falling into a white dwarf is a one-way trip with a very, very quick end. First, the tidal forces would stretch you into a stream of atoms. If you survived that, the extreme heat and radiation of the atmosphere would vaporize you. If you survived that, the incomprehensible pressure would crush you into nothingness. And if you somehow, magically, survived all of that, the impact with the crystal-like surface would result in your complete and utter annihilation. While it's a terrifying scenario, studying these extreme objects helps us understand the fundamental laws of physics and the life cycle of stars. White dwarfs are the future of our own sun, billions of years from now. They are the beautiful, dangerous ghosts of stars that once shone brightly in the cosmos. They remind us that the universe is filled with wonders that are far more extreme and fascinating than we can possibly imagine. So the next time you look at the stars, remember the incredible forces at play and the strange, dense stellar remnants that lie hidden in the darkness. Thank you so much for joining me on this cosmic adventure today. It's a wild universe out there, isn't it? If you enjoyed this journey into the extreme, please hit that like button. And don't forget to subscribe and turn on notifications so you won't miss our next exploration. What cosmic mystery should we dive into next? Let me know in the comments below. Stay curious, and see you in the next video.